Okay, so today I will show you how to make 7-segment display that's quite special. Because once I remove this frosted acrylic plate and also this 3D printed part, you can see that this display is actually on the breadboard. And that of course means that you don't need to do any soldering and you don't need a custom PCB, but if you do need a custom PCB, you can use the link down in the description and get 10 PCBs for free, only paying for shipping, because the sponsor of today's video is PCBWay, but more about them later. For now, let's talk about this project. So there are 7 LEDs placed on the breadboard, being driven by the Arduino UNO. On top of those LEDs is a 3D printed part. You have already seen this one, where there is nothing on the top, so you can cover it with anything you like this frosted acrylic plate or anything that's semi-transparent. I also have the second 3D printed part, where the top diffuse layer is already 3D printed and you don't need to do anything else. You just put it over those LEDs and suddenly you have a 7-segment display. But before we get to this 3D printed part, let's talk about those LEDs. Those LEDs might look like a standard RGB LEDs because they have 4 legs, so you might think those are for red, green, blue and common ground, but that's actually not true. Those are actually NeoPixel LEDs, the individual addressable LEDs, the proper name is WS2812. And I'm sure you have seen those before, but they usually look like this, like a small rectangles or tiny little rectangles. Those are SMDs, the surface mount devices, whereas our LEDs are through-hole, which means that they are legs sticking out of the bottom of the LED and you can easily use them on the breadboard. There are 4 connectors in total. We need 2 for power and ground and 1 for the signal for the data. So if the LED receives the data that it should show the red color, it will show the red color. However, if it receives another data shortly after that, it will send the previous data for the next LED, and that's what the last connector is for, that's the data out. So you can use the data in and data out to connect multiple LEDs together. You can get the through-hole NeoPixel LED in either the 8mm size or the 5mm size. I actually have the 5mm in both the clear version and the frosted version, but today I will use the frosted 8mm version, so the bigger one. Okay, so we've covered the LEDs, let's move on to the breadboard. If I flip it and remove this protective cover, you see how those individual holes on the top are connected. For the power rails, they are connected like this from top to bottom, and for those inner rows, they are connected like that from left to right. That means that we cannot insert the LED like that because all the pins will be connected, so instead we need to put the LED into the breadboard like this. Now since those rows are connected from left to right, we can only have 1 LED on the left side and 1 LED on the right side. That should be fine for today's project, because for a 7-segment design, we don't need more than 2 LEDs next to each other. Now you can try to place those LEDs on the breadboard to see how it looks like, but I actually found it easier to do that on the PC. However, before I do that, let's talk about the sponsor of today's video, which is PCBWay. And that's because if you are making electronic projects, sooner or later you might need PCB or PCB assembly or SMD stencils, and in all those cases, PCBWay has you covered because they offer all of those services for a reasonable price. On top of that, they offer services like CNC machining, 3D printing or injection molding. So thank you PCBWay, and let's get back to our project. And let's actually try to visualize the placement of those LEDs on the breadboard. So I have a breadboard in here and the spacing between those individual pins is 0.1 inch or 2.54 millimeters. But what might not be obvious is that you can imagine that between the left section and the right section, you can actually fit 2 more holes. So this is the spacing between the left section and the right section, as if there were 2 more pins in between. So let me actually redraw it on the side to have some reference. And again, the spacing is 2.54 millimeters and I need 12 of those. But as we've already mentioned, the middle 2 are actually not there, so I'll delete those. So I have 5 on the left side and 5 on the right side. And then I will duplicate them also in the other direction, and I believe there are 30 of those. So this is the visualization of the breadboard. I've also created the visualization of the LED itself with all those pins, so the data in, the plus, minus and the data out. And now I will just place it on the breadboard, so maybe the first could be in here on top. And as we've already discussed, those rows are connected from left to right, so we cannot place anything in this position, which means that if we copy and paste this LED one more time, it has to be offset by 4 pins. And if you imagine how the 7-segment display looks like, this also has to be offset to the left and right side. So let's use the same offset of 4 pins to right and then 4 pins to left. And thankfully we've jumped over this area where we cannot connect anything, which is great. So let's use the very same spacing also for the other LEDs. So this one will be offset by 8 from top. And then I will just copy and paste those 3 in a way that they are offset by 4 and 4. Okay, so this might be the final layout. And if we overlay the 7-segment display shape, I think it might fit nicely. Now this is not the only way how to fit the 7-segment display on the breadboard, because we have a lot of space down here, which means that we can use a bigger vertical spacing. Instead of vertically offsetting those LEDs by 4 pins, we can also offset those by 5 pins or 6 pins. And all of those versions would still fit on the breadboard. You can actually offset those LEDs by 3 pins as well. And that's because if you look closely, those rows are connected, but it's actually not a problem because this is data out coming into data in, and here data out coming into data in, and so on and so on. So it should be possible to have this layout as well if we need to. Now I was thinking, can you make a skewed version of this display? Meaning something like this, so skewing the shape and changing the angle of the digit. And unfortunately this doesn't seem to be possible. If we decide to move those individual LEDs to the left side, so those 2 will be moved by 1, the other one will be moved by 2, those 2 will be moved by 3, and finally this one will be moved by 4. We do have this skewed shape, but unfortunately this middle LED ended up on this empty area where there are no pins, no connectors, so it wouldn't be possible to connect it to the breadboard, and we would have to move it either to the left side or to the right side, and so this segment might not be lit evenly. So yeah, no skewed version. For today I will go with this version where the spacing, the horizontal spacing and the vertical spacing between LEDs is exactly 4 pins. So let's do that, but before I use the real breadboard and the real LEDs, I will try to simulate the layout of those connections on the breadboard. For the simulation I will use Vokvi, which is a free online Arduino emulator, and I will create a new project using the Arduino UNO. But for now I actually don't care too much about the used board, because what I want to do is to add a new breadboard. So clicking the plus icon I can add a new component, and I'm looking for the breadboard, and the one that I have is the half breadboard, so just insert it into the canvas and then press the R key on the keyboard to rotate it by 90 degrees. And let me zoom in a little bit more. And of course on the breadboard we will have our NeoPixel LEDs. And while there is a NeoPixel in the component list, it's only the SMD version, which I guess we can add to the breadboard, but the connections will not be correct, so let's just not use it. We might use the standard RGB LED, but again, here those connectors are somehow not aligned in one line, so that might be kind of confusing. So with all that said, what I will do is I'll just draw one line going from here to here, and then change the connector color to, for example, this light pink. And then let me try to draw the circle around this one. So this is our NeoPixel LED. And I can continue like this with all the other LEDs. So they should be placed on those positions. Let's change the colors for all of them. And let's try to draw those circles. Yeah, it's not perfect, but hopefully you get the point. Let's connect the 5 volts and the ground for the first LED. And while we can connect the plus the 5 volts to this pin, we've already said that this row is connected, so all we need to do is to connect it, for example, to this pin, and then minus the ground will be connected to this pin, but we can use this one instead. Let me also change the color, so the black for ground and red for 5 volts, and do the very same thing for this LED as well as this LED. In a very similar way, we can continue on the left side, so this should be also 5 volts. And this should be also ground, and this should be also 5 volts, and this should be also ground. Now this LED and this LED is not yet connected to 5 volts and ground, and if we take the 5 volts from this side, we will somehow intersect with the legs from the LED itself. So maybe a better idea would be to connect the 5 volts from here, so over this bridge, and the ground as well. So again, this is 5 volts and this is ground. And do the very similar thing for this LED, so going from this for the 5 volts, and this connector for the ground. So now we have 5 volts and ground connected for every single LED. Obviously later on we will connect the 5 volt rail to the 5 volt on the Arduino UNO, as well as the ground rail to the ground pin on the Arduino UNO, and make sure that those two rails are interconnected, like so. The next step is to connect the data pins, so some signal will be going from the Arduino UNO, and I already know that the pin being used is the pin number 6. So pin number 6 should be connected to data in for the first LED, which is this one, so this is data in. Let me change it to green color. And then the data out, which is this one, should be connected to data in for the second LED, so we can connect it, for example, in here. But we can also connect it in here or in here, it doesn't quite matter which connections we use. Any of those is fine. I will use the middle one and change the color to green. And then this data out should be connected to this data in, so again the same connection. And one more time, data out going to data in, and data out going to data in. On the left side of the breadboard it's slightly different because this is the data out. But it should be connected, let me actually do it this way. It should be connected to data in, which is here on top, so we should connect this pin to the data out from this LED, so it goes to the top pin. And here the data out pin is this pin, which should go into the data in pin on the very last LED, which is the one on the top. And I guess that this is all that we need, so this is the connection of the LEDs on the breadboard. Which means that all that's left to do is to do it on the real breadboard with real LEDs. Now for the connections, I'm using those breadboard wires, which you can get very cheaply on AliExpress, and as you can see they are in many different colors and pre-cut to many different sizes. I'm also using this 3D printed breadboard holder to hold the breadboard next to the Arduino. I will put the link to that file in the description. On those LEDs, one of the sides will be flat, and that's where the data out pin is. You can also look at the length of those pins, and the longest one is the ground pin. And so after a while, the connections on the breadboard should be the same as inside our Walkwie simulation. Which means it's time to connect the Arduino to the PC using the USB cable and jump into the Arduino IDE. Inside our Arduino sketch, we want to use the Adafruit NeoPixel library, so jump into Libraries and type in NeoPixel. And there are quite so many libraries, but we want to install this one, which is called the Adafruit NeoPixel by Adafruit. So click the install button if you don't have it installed already. And then we will go to File, Examples, Adafruit NeoPixel library. And let's for example open the one which is called the strand test. Inside the sketch you can see that the pin for data is set to pin number 6, which is good because we've already connected the data to the pin number 6. And then we have the number of pixels, and in our case we only have 7 pixels, 7 LEDs. And I guess that's all that we need to do, so let's just select our Arduino UNO in the drop-down menu, make sure it's connected to the correct port, which seems to be the case, and then hit the upload button. And if everything is correctly connected, we should see some colors on those LEDs. In the beginning it's being filled by different colors, then it's blinking a little bit, again in different colors, and then there is the rainbow animation. And while it all looks perfect, later on I've realized that there is actually something wrong. If I jump back into the Arduino IDE and open a different example, so again going to File, Examples, Adafruit NeoPixel, and open this one called Simple, and again keep the pin to pin number 6 but change the number of pixels to be 7. The code down here says that it will light up those individual LEDs with bright green color. But if I upload it to the Arduino UNO, those LEDs are not green but rather red. And I think it has to do something with the initialization and all the used options. In here we are defining the number of pixels and on which data pin it will be sent. And the next option is a color format, currently set to GRB, so green, red, blue. And I think that we should use the RGB instead, so red, green, blue instead. So let me try to upload it one more time. And sure enough, now those LEDs are green as they are supposed to be. To finish our Arduino sketch, I think that we can update the code in a way to light up those individual LEDs in a way to form those digits. And of course counting from 0 all the way to 9. As a starting point, I will use my older video, which is for creating the 7-segment display using the NeoPixel strips. And that's because down here there is a link to the walkway sketch. And if I open it and run it, you can see that it's doing the very same thing, counting from 0 all the way to 9. The only difference is that I'm using 3 NeoPixel LEDs for each segment, whereas for today's project, we only have 1 NeoPixel LED for each segment. So I will copy the code into the clipboard and paste it into the new sketch in the Arduino IDE. And if I scroll all the way up, you can see that we have the LED pin being set to pin number 6, which is the same pin that we are using today. But the number of pixels, number of LEDs should be set to only 7. Here I have the visualization of those segments, and this is the usual layout used for 7-segment displays. But we don't have the LEDs connected like that, we don't have it connected like A, B, C, D, E, F, G in this layout. We have a slightly different layout. Starting from this, going to here, and then to this LED, and then this one, the last one on the bottom, and then on the other side of the breadboard, it's being connected like that. So let me write down those indexes. So this is the first LED with the index of 0. The next one is the index of 1, then the LED number 2, then going down LED number 3 and LED number 4 on the very bottom. And then on the left side, this is LED number 5, and the last one is LED number 6. So those are the indexes that we will be using in our code. And this section of the code is to light up one segment, and I will actually delete all the rest of the code, because we need to make some changes. As a starting point, we are lighting up 3 individual LEDs for each segment. But again, we only have 1 LED today, so I will delete those 2 LEDs for every single segment. And uncomment the last line. And then we need to fill up those indexes, so A is 0, B is 1, C is actually different, C is 3, D is 4, E is 5, F is 6, and finally G is 2. And because the digit number 0 looks like this, the segment number G should not be shining, so I'll just comment out the segment number G to not show it. The next step is to of course add more digits, so let me just copy this and paste it. And for digit number 9, let me just visualize it. I don't want to show the segment E, but I do want to show the segment G. And let me continue like this with all the other digits. And once all that work is done, we can hit the upload button to upload our sketch to the Arduino board. And we do see those LEDs lighting up in different colors, although at this point it's kind of hard to imagine some of those numbers. So I think it's time to create the 3D printed enclosure to spread the light into those individual segments. I will create the 3D model in Autodesk Fusion, which you can use for free for non-commercial use. And in here I will start by creating a new sketch on the floor plane, so click the new sketch and then click on the floor. And of course the first thing I want to do is to draw our LED in the middle, in the center of the design. So select this tool, the center circle, and then click to the origin. And the diameter of our LEDs is 8 mm, but there might be some variations, so just in case I will enter 8.5 mm. And that will be our LED in the center, and then we want to create another LED in here with the same diameter, 8.5, and another LED will be on the left side, 8.5 mm. And you can see that we use the very same number for all of those LEDs. And if we decided we want a different number, different diameter, we would have to change it on every single occurrence. So instead of doing it like this, we can go to Modify and select Change Parameters and create our new parameter by clicking this plus icon. And let's call it LED diameter. And of course the expression, our value, will be 8.5 mm. So click the OK button and OK button. And then we can double click this value, and instead of typing in the value, we can type in LED diameter and hit the Enter key. And do the same thing in here. And one more time in here. We want to set the spacing of those LEDs. And we know that for our design, they are moved by 4 pins. And again, one pin is 0.1 inch or 2.54 mm. I will do the very same thing by adding a new variable, new parameter, and let's just call it X spacing. And it will be 4 times the pin spacing, 2.54. Click the OK button and also add the Y spacing, which in this case is the same 4 times 2.54, but we might change it in the future. So click the OK button and then select this tool, the Sketch Dimension tool, and we will set the distance of this LED from this LED, and of course it will be the Y spacing, and that will be the same for this LED, so again this will be the Y spacing, and then this distance from this LED to that LED, that will be the X spacing, and same in here, so this will be also the X spacing. In a very similar way, I will also create the other LEDs, so the diameter is the LED diameter. I need one more LED in here, and actually we need one more LED in the middle, and I will start by dragging the cursor over the center and then move it down, so you can see this dotted line, the helper line, to stay inside the center, and then again draw the LED with the LED diameter, and in the same way I will start in the center and then move my cursor to the top to have this dotted line, and draw the last LED. Let me quickly set all the positions with the X spacing and the Y spacing variables, again using the Sketch Dimension tool. When we have all of those LEDs in place, let's just create some kind of outline, and for that I will use the rectangle and just draw it in any size and actually not enter any dimensions, because I want this to be offset from the circles. And for that I will create a new variable, new parameter, and let's call it outline offset. And as for the size, I don't know, maybe 8 mm for now. Click the OK button. And then I want to set the offset from this circle to the side of the rectangle, and that will be the outline offset. And do it also on this side, for example from this LED. So this should be also the outline offset. Also on this side from this LED, again outline offset. And finally on the bottom, so the bottom side should be offset from this LED. And the size will be again outline offset. So I think that we have all that we need, so click the Finish Sketch. And let's just rename our sketch to be LED Positions. I will change the camera angle a little bit, and I want to extrude this by clicking on this element. And I want to extrude it, for example, by, I don't know, 15 mm. So you can imagine that this part will be on top of those LEDs, but of course we still want those segments to be cut from this shape. So for that I will hide the body for now and create a new sketch again on the floor plane. And I want to draw one segment. I will most likely also show the previous sketch so I can kind of see the dimensions. And then I will draw the rectangle, but actually not this one, but if I click the create, I can select the center rectangle going from the center. So let's just draw a rectangle from the center. And as for the size, let's for example start with something like maybe this, like 18 mm. And the height of course should be bigger than the LED itself, so let's go with 9 mm for now. Let me hide the previous sketch, and since this is not the shape that I want for the final segment, I will select everything and turn this into the construction line. So this shape will be only used as the helper object. As the next step, I will select the line tool and draw the shape of our segment at least roughly. So this should be in here aligned, this should be going to this point, and from this point it should go to the bottom line, and again to the left side, to this point, and finally to the first point. And it looks nice, but those blue lines means that this shape, those blue lines are actually not being constrained, so you can move those freely around, and that's not what we want. We want to specify the angle of those lines. So select the Sketch Dimension tool, and we will sketch this angle, which should be 135. So the other angle is 45 degrees. And in the same way, this should be also 135, as well as this one should be 135. And finally, this angle should be also 135. And I think that this shape could be our segment, so let's just click the Finish Sketch and rename the sketch to be Segment. And then I will change the camera angle and again use the Extrude tool to extrude this shape by the same amount of 15 mm. So 15 mm, click the OK button, and this is our one segment, and of course we need more of those. So as the first step, I will select the segment. I want to rotate the segment to be on this position, and for that I will select the segment and select the Move Copy tool. First set the pivot point to be in the center, so click the Set Pivot Point and click on the center of the face, and then click Done. And I'm not quite sure which axis it should be, so this is not the right axis. This is also not the right axis, which means that it should be the Z-axis. The Z angle should be 90. Click the OK button. And then I will select it again and select the Move tool again. And I want to move the point to point. The origin point will be our point in the middle of the shape. And the target point will be, of course, this circle. Then click the OK button, and then we can either copy it one more time, or I guess we can use the mirror tool, so create mirror. And the mirror plane should be this plane. Click the OK button, and actually do it one more time, create mirror. I will select those two bodies, and the mirror plane will be this plane, and again OK button. And then I will extrude the segment one more time, again by 15 millimeters, that will be the center one. And again, use the move copy to copy this segment to a new point. So this will be, actually let me hide those other bodies so they are not getting in our way. So this is the origin point, this is the target point, and I want to create a copy. And the last body could be probably also mirrored, so mirror by this plane, if I can select it, and click the OK button. So in the end, we should have 7 different segments. And of course our main body shape. And what we want to do is we want to remove those segments from the main body, from the main shape. But we don't want to start all the way from the bottom, because in the bottom we only want to have those circles, and those segments should be slightly above. So before we do any subtraction, let me just select all those segments, so show all those segments, and then select the move tool again and select all of those segments. And let me just move it on the z-axis by 2 millimeters. Click the OK button. Then show all of those bodies and select modify combine, and the target body is our main body, the big one, and the tool bodies are all the other bodies, so going from 2 all the way to 8. The operation shouldn't be join, but it should be cut instead, and if I click the OK button, now we have nice holes inside our main body. Now to see the shape better, I usually change the appearance, so right click and select appearance, and select one of those light appearances, for example the metal aluminum, it doesn't quite matter which one, and that will make the model slightly lighter. And I think it looks great, but before we 3D print it, let's make few adjustments. I feel like the distance between those segments could be slightly smaller, and that the dimension is inside our segment sketch, which is those 18 millimeters, so let's try to go with 19 instead and click the finish sketch. And I think that now it looks better. We can also change those corner shapes to go more into the corner, like so. And for that we can use the offset face tool, so select offset face tool and select those two faces. And offset them, for example, by 3 millimeters. And of course we want to do that for all the corner faces. And to add to the selection, click the Ctrl key on the keyboard and add those two faces. And then rotate the camera view, like so, and also add those 4 faces into our selection. And I think it looks much better, so click the OK button. The very last thing that I want to do is to chamfer or round those corners. And I guess I will go with rounding, so select the fillet tool and click this edge and also this edge. And then round it a little bit, maybe by 4 millimeters. And this looks fine, so rotate the camera view, click the Ctrl key on the keyboard and add those 2 edges to the selection. And click the OK button. And I guess this could be our final shape. So let's just try to 3D print it. I will first rename the body to be Breadboard 7 segment, and then we can right click and select Save as Mesh and save it as a 3MF file. Or I guess we can also go to File and select 3D Print. In the preparation type I will select Print Utility. I have already used the Bamboo Studio before, so just click the Bamboo Studio. I want to export our Breadboard 7 segment. And then click the OK button. And that should start the Bamboo Studio application and open our 3D model. For 3D printing I'm using the Bamboo Lab X1 Carbon with a default 0.4mm nozzle. And for the actual material I will go with the PLA matte in the white color. I don't think that I need to change anything, so just click the Slice Play button. And just see how it looks like, and since I don't see any problems, let's just click the Print Plate button. And here click the Send button to send it to the 3D printer. The printer will do some calibration and then it will start printing. As you can see, it takes about half an hour to print this piece, so let me speed it up for you. And unfortunately it's hard to see any details on the white filament because of the lighting conditions, but it's still great to have this live stream. Once this piece is 3D printed, we can put it on those LEDs. And once we put something diffuse on top of it, like for example the piece of paper or maybe this frosted acrylic piece, we do have a 7-segment display. However, I would like to update our design to also include this top layer being 3D printed, the diffuse layer being 3D printed, and I guess that all that we need is to have just one extra layer on top of everything. The problem is if I print it in this orientation, it might work, but it will definitely not be flat. So what we want to do is to print it upside down, meaning the top layer, the diffuse layer, will be the first layer. But there is also a problem, because if we print it like that, the inner parts of those segments, they have no supports, they are just floating in here, and they might be impossible to print. So I think that the first step is to adjust the geometry of the inner parts of those segments in a way that there is a smooth transition between the shape of the segment and the bottom circle. If we do it like that, then it might be possible to print this shape in both orientations. So one more time, I want to create a smooth transition between the segment and the circle inside. And we already have the sketch with all those LEDs, with all those individual circles, but we also need the sketch with all those individual segments. And for that I will create a new sketch on top of our 3D model, so click the Create Sketch button and then click the top plane of our 3D model. And let me actually change the camera view, and we want to project the front plane into our sketch. And to do that, hit the Create button and select Project Include and click the Project button. And then click the front plane and click the OK button. And if we hide the body, you can see that now we have the sketch with all those individual segments. Let's rename it to All Segments, project it, and click the Finish Sketch button, and then show both the All Segments projected sketch as well as the LED positions sketch. And we want to create a smooth transition between the segment and the circle, and for that we will use the Loft tool. So from the Create menu, we'll select the Loft tool, and then first select the segment, and then select the circle. And I don't think that we need to change anything else, so just click the OK button, and we have our smooth transition between the segment and the circle. So let's do that 6 more times for every single segment. So again, Loft, segment, and the circle, click the OK button, and continue like this with all the other segments. This is how all those segments look like. If we want to see the transition, we can go to Inspect, Section Analysis, and click this floor plane, and then use this arrow to see the transition between the circle and those individual segments. And I think that this is something that we can print from both orientations, which is great. So just hide the analysis, and we want to subtract all those segments from our main body shape. However, if I show the main body shape, this is already pre-cut with those old segments, and that's what this combine function is for. But if we don't combine it, we wouldn't be able to project this sketch. So instead of trying to reuse this body, let's create a new one by extruding these LED positions. And let's again extrude it by 15 millimeters, so 15 millimeters. Click the OK button, then show all of those individual segments, and select the main body and use the very same comment as the last time, which was the combine comment. This is our target body, and for tool bodies, that will be those 7 segments, and the operation should be set to cut. And if I now click the OK button, you can see that now we have those transitions going from circles to our segments. Let me just change the material to be slightly lighter. And then if I create another section analysis, but this time on this plane, you can see that it goes between the segment and the circle. But the last time we had this small rim down there, so small rim for the LED itself. And we can add something similar by extruding the shape from the bottom. So let's just select the extrude tool one more time and extrude the bottom of the shape by 2 millimeters to add this small rim. Let's hide the analysis, and before 3D printing this, let's use the same rounding for those corners by using the fillet tool. And let's select all those edges, also this one, and I think that we were using 4 millimeters. Finally, let's rename the body, and then again select the file, 3D print, and click the OK button to start the Bambu Lab Studio, the 3D printing application. Use the very same settings as the last time, but this time we want to print this upside down. So with the shape still selected, select the Rotate tool, and then rotate it in on this axis, and if I hover over those lines, it will snap to those increments, and we want to rotate it by 180 degrees like so. Then click the slice plate button, and as we show it layer by layer, there should be a smooth transition between those segments and those circles, which means that there should be no need for any kind of support. So yeah, everything looks fine, so let's try to 3D print it. Click the print plate button, and then the send button to 3D print it. And here is a quick time lapse straight from the 3D printer. And here's the 3D printed piece. I actually have two of them, and while they look the same, they are not. Judging by the rough texture, this was printed like this, so this side touching the plate. And for the second piece, this side has the rough texture, so this side was touching the plate. So it prints perfectly fine in both orientations, and as expected, we can still put those pieces over our LEDs to form the 7-segment display. So let's do one last step, and that is to print the very same piece, but this time with the diffuser layer on top. Actually, it will be on top once we put it over our LEDs, but during the 3D printing process, it will be on the very bottom. It will be the first layer on the plate. And because I'm currently printing with the layer height being 0.2 mm, if we make the diffuse layer being 0.2 mm tall, it will be printed with exactly one layer. So let's jump into Fusion and do that. And I think that all that we need to do in here is to hide the 3D body for now and show the sketch called All Segments Projected. Select the Extrude tool and select everything. And then hide the sketch and show the 3D body and extrude it by 0.2 mm. That will create the diffuse layer and we cannot see anything inside. But if we want, we can still use any of our section analysis to show the inside of the model. If we want to move the section analysis, we can right-click the section analysis and select Edit, and then use this arrow to move the section analysis. And I think that everything looks fine, so let's 3D print it one more time. Again, File, 3D Print. Click the OK button to open the Bamboo Studio again. In here, let's not forget to rotate the object using the Rotate tool, in a way that the diffuse layer is the one on the bottom. And after we click the slice plate button, we can still check the inside of the model to see if everything looks fine. And we can even use the bottom slider, and if I move it one layer on top, there should be nothing on the bottom because again the diffuse layer is just one layer, which is this one. And since everything looks fine, let's 3D print it. So again, print plate and print this final 3D model. Here is the last time lapse. And here is the final 3D printed piece. And I really like how you can just slide this piece on those LEDs and turn them into a 7-segment display. And that's all for today. As usual, all the source files are on GitHub, the link is in the description. If you have any questions or comments, please put them in the comment section. Thank you very much for watching and I hope to see you soon. Thanks and bye.